We've talked about some irreversible addition to ketones and aldehydes from really strong nucleophiles like the Grignard reagent, like beta-lithium, and stuff like that. So let's talk about some weaker nucleophiles that can add reversibly. That is, they can add in and then they can come back out. So one of those nucleophiles is cyanide. And so we can talk about this in terms of hydrocyanation. So we'll end up adding hydrogen cyanide gas, HCN, and then we get this cyanohydrin. So we've learned about bromohydrins already. This is a cyanohydrin. We usually are not going to go buy HCN. We will usually make it from sodium cyanide, which is a powder, and then treat it with acid. The mechanism for this reaction is pretty straightforward. Like I said, we're going to make our HCN by adding acid, strong acid, hydrochloric acid, to sodium cyanide. And we're not going to add them one-to-one. We'll have at least a little bit of excess cyanide in there because that excess cyanide will start the mechanism off. So I'll end up with this negative charge here. My negative charge will attack my carbonyl. Again, nucleophiles attack that carbonyl carbon. The electrons will then go up onto oxygen. We'll end up with this tetrahedral intermediate, which then will find a proton. And it'll probably find a proton from the weak acid HCN, which generates some cyanide on the back end. So really this is catalytic in cyanide anion. That's the mechanism by which we get these cyanohydrin products. So as I said, this is at equilibrium. And so how can we force this equilibrium to go further to the right if we really want the cyanohydrin? So one way to push it to the right is to use excess cyanide, right? So this is Le Chatelier's principle. If I add more reagents, if I add more HCN, then I will push the equilibrium to the right to make more cyanohydrin. Another way that's maybe less obvious is to use unhindered carbonyl compounds. If we use aldehydes, now this H takes up much less space, and so the cyanohydrin overall is less sterically crowded, so it's going to be more stable. And so it's much easier to make these cyanohydrins from aldehydes and get them to stick. It's much easier to do that than to make them from ketones. Sometimes the ketone cyanohydrin is just too crowded, and so it just won't stick. It'll revert back to the ketone. Again, the equilibrium in that case will lie very far to the left.